All right, we're going to go ahead and work on lesson 19.4, algebraic representations of transformations. We're just going to be putting into play everything that you learned about translations and rotations and reflections, but we're going to do it algebraically because there are ways to use the coordinates and different operations to help us represent transformations. So in the case of translations, where all you're doing is moving either left, right, up and down along a straight line and not changing the shape or size of the figure, we're going to go ahead and be able to add or subtract from the coordinates to be able to find their new locations on a grid. So for example, in here, if I want to move right a units, and I know that moving right is along the x-axis, and I'll make that note, x-axis is left or right, and y-axis is up or down. If I know that I want to move left or right a units, I'm going to add a units, whatever they are, to my x coordinate. And if I want to go left a units, I'm going to take away that many from my x coordinate. But if I want to go up or down certain amounts of units, I'm going to take that or add it to the y coordinates because it's moving up and down. So in the case of this triangle down here, for example 1, it says triangle XYZ has vertices x at 0, 0, y at 2, 3, and z at 4, -1. It's asking us to find the vertices of triangle x, y, and z after a translation of 3 units to the right and 1 unit down. So if I'm thinking to the right, you should be telling yourself that we're moving along the x-axis. Hopefully you were correct. And if I'm moving down, hopefully you're telling yourself that is the y-axis. So whatever operation we have to do to move up, down, left, or right, we're going to do to those specific coordinates. So here are the vertices for this triangle, the pre-image, right? If my rule is to move right, I am going to add 3 to my x-axis because adding keeps moving me towards the positives, further away from the origin and the negatives. So I'm going to add it. And if I'm moving down, I'm going to take 1 away from my y coordinate because I don't want to move into the positives. I want to move down to the negatives, right? So in the case of x at 0, 0, I'm going to add 0 plus the rule of 3 to the right to get a new coordinate for x as just 3. And if I'm taking 1 away to move down from y, I'm going to do 0 minus 1, which is -1. So my new x coordinate, and I will locate it, should be at 3, -1. So first the x, 3, -1. Then I have my y coordinate. The rule is adding 3 to x, so I'm going to add 2 plus that rule of 3 to get 5. And I'm going to take away 1 from y, so 3 minus 1 to get a new coordinate of 2. So my new image for the point of y is going to be at 5, 2. So I'm going to count 1, 2, 3, 4, 5, 1, 2. And then for z, it's 4, -1. So I'm going to add 4, the x coordinate, to my rule of 3. So 4 plus 3 is 7. And I'm going to take 1 away from -1. So -1 minus -1 minus 1, right? Minus 1, which is going to be -2 because I combine these two. So my new point for z is 7, -2. And I'll connect the dots to make my new image of the pre-image, and I'll label them with their notations. This is z notated, y, and x. And what we did there was follow algebraic rules for translations, knowing that we add and subtract if we want to move right and left on the x-axis from the x coordinate, and add and subtract if we want to move up and down on the y-axis from the y coordinate. Right? Because nothing changes in the shape and size, it's only its location for a translation. Let's go ahead and put that into practice for number 1. It says a rectangle has vertices at 0, -2, 0, 3, 3, -2, and 3, 3. What are the coordinates of the vertices of the image after the translation? If it's telling me the rule is to move, which way do you think? Is this moving me left or right on the x-axis? Hopefully you're telling yourself left because we're taking away 6. And is this moving up and or down on the y-axis? Hopefully you're telling yourself down because we're taking away 3. So my rule is -6, -3, right? Whatever I have on my x coordinates, I'm going to take away 6, and whatever I have on my y coordinates, I'm going to take away 3. So let's start with 0, -2. I have 0, -2. So I am going to do, with my x coordinate, 0, -6, and then I have -2, -3. So my new coordinate is going to be -6, -2 minus 3, -5. Let's do that with other points. For example, 0, 3. 0, 3 is going to have 0, -6, and 3, -3, which is going to get us -6, 0. Let's keep going with 3, -2. I'll use some space. I have 3, -2. I'm going to do 3 minus 6 and -2 minus 3 to get 3 minus 6 is -3, -2 minus 3 is -5. And the last one I would do is 3, 3. So I'm going to have 3, 3 is going to have 3 minus 6 and 3 minus 3, and we'll kind of move up with that one. 3 minus 6 is -3. 3 minus 3 is 0. So the new vertices for my new rectangle are going to be -6, -5, -3, 0, -6, 0, and -3, -5. How about for reflections? The signs of the coordinates of a figure change when a figure is reflected across x and y. The table shows the rule for changing the signs of coordinates after a reflection. For a reflection, if I'm going to reflect across the x-axis, I'm actually going to multiply my y coordinates by -1. And if I want to reflect across the y-axis, I am going to multiply each x coordinate by -1. So I'm basically doing the opposite. So the rule is reflect across x-axis, multiply all your y's by -1. Reflect across the y-axis, you're going to multiply all your x's by -1. So basically you're just flipping based on the axis. So rectangle RSTU has these vertices. Find the vertices of rectangle RSTU after a reflection across the y-axis, then graph it and its image. All right, so here across the y-axis, if I'm reflecting, that means every x coordinate is going to be multiplied by -1. So in this case, the rule here is every x times -1, and all my y's stay the same, no change. So I would do -4 times -1 to just get +4. -1 times -1 to get +1, -1 times -1 to get +1, and -1 times -4 to get 4. So my pre-image, the original, is here. And now that I've reflected over my y-axis, now that I've reflected over my y-axis, all of my coordinates for x, for the x values have changed to positives because I multiplied them times -1. And I have a direct reflection. Let's us put it into practice. The triangle ABC has vertices A, B, and C at these coordinates. Find the vertices of the triangle after reflection across the x-axis. Tell yourself, what does the rule say if I'm reflecting across the x-axis? What am I actually multiplying? hopefully you're telling yourself that you're multiplying all of your y coordinates times -1. So I'm just going to write the rule here. Multiply all y coordinates times -1. Okay, and let's see what happens. If I multiply this times -1, I have the new coordinate of -2. And what's 6 times -1? -6. Here I would multiply times -1, so 0 would stay the same, but 5 times -1 is -5. And here I would also multiply times -1. The 3 would stay the same for x, but I would do x -1 times -1, which is just 1. So you're basically multiplying the opposites, okay? Now, how about a rotation? This makes it much easier to work with. How about a rotation? When points are rotated about the origin, the coordinates of the image can be found using the rules shown in the table. So here's the table. If I am rotating 90 degrees clockwise, I am going to multiply each x coordinate by -1 and then just switch the x and y. Sounds really weird, but all you're doing is following the rules. So 90 degrees clockwise means every x coordinate gets multiplied by -1, and then you flip your y and x. For 90 degrees counterclockwise, you're going to multiply each y coordinate by -1, and then flip your x and y. And for 180 degrees, you're going to multiply both coordinates by -1. And there's no flipping necessary because this is us just doing the opposite of what we have. And so that's why we would multiply it by a negative, and we would see the direct rotation of it across the origin or whatever the point of origin is. So all I want you to do is follow these rules, okay? And so we're going to read to see what it wants from us, and we're going to come back to the rules to see how to use them. Quadrilateral ABCD has vertices A, B, C, D at these points. Find the vertices of quadrilateral ABCD notated the original after a 90-degree clockwise rotation. All right, 90 degrees clockwise, meaning I am coming back to this first rule. So I'm going to write all my vertices here like the table has, and I'm going to follow the rule. The rule says multiply each x coordinate by -1. So we're going to multiply all of these x coordinates by -1. 2 times -1. A, B, C, D. So it actually already flipped our x and y coordinates here. So my x is the -4. So I'm going to do -1 times -4, which is 4. Here it flipped it already to x and y. So I'm going to do -3 times -1, which is 3. Here it flipped also. So the 2 is my x coordinate. So I'm going to do -1 times 2, which is -2. And 0. 0 times -1, 0. So my new quadrilateral would be A, B, C, D after a rotation of 90 degrees clockwise. And all you did was multiply each of these x coordinates times -1, and then flip them with x and y. So let's put that into use. A triangle has vertices JKL at these points. What are the coordinates of the vertices of the image after a triangle is rotated 90 degrees counterclockwise? Let's go back. 90 degrees counterclockwise tells me each y coordinate has to be multiplied by -1, and then switch x and y. So let's go ahead and do that. Every y coordinate, so multiply y coordinate by -1, then flip x and y. Let's go ahead and follow that rule. So I'll start with j. Point J is -2, -4. I will go ahead and multiply the y coordinate by -1. So I'm going to stay -2 the same, but it's -4 times -1, which gets us -2 for x still, and -4 times -1 is 4. So this is just us multiplying the y coordinate by -1, and now we flip. So our final j prime is going to be 4, -2, right? Now that we found that new y coordinate, we flip 4, -2. Let's try that for k. We have 1, 5. So I'm going to multiply my y coordinate by -1. So the 1x stays the same. 5 times -1. I'll leave it all the same still. 1 and 5 times -1 is -5. And now that we've found our new y coordinate, we flip. So our new k prime for the original picture or triangle is -5, 1, because we flip them. That's what the rule says. And for L, we have 2, 2. I'm going to leave the x coordinate to the same, but I'm going to multiply my y 2 times -1. The 2 will again stay the same for the x. 2 times -1 is -2. And now that we found our new y coordinate, we flip. And our new L prime, or L notated, is -2, 2. So all you're doing is going and following the rules that are given to you about translations, rotations, and reflections. And you're going to go ahead and try that on your homework. We're going to try numbers 5, 6. Sorry, I'll write that down here for you. Numbers 5 through 10. And just take your time on number 10 because 10 is asking you to focus on the half units as well. Okay? Good luck.